with my assistant,
Calvin.
Alright, today, polar coordinates. That's what we're learning about, by the way. We're learning about polar coordinates. Polar coordinates is another way of plotting points on a plane. Instead of x and y on the Cartesian or grid plane, a point is plotted using the distance from the origin, represented by r, the radius. Alright? The angle of the line that goes through the origin and the point.
This angle is measured counterclockwise from the positive x-axis to the line that goes through the origin and the point in question.
This point is represented by theta. There are many cases in where polar coordinates is much easier than the Cartesian plane.
To graph a point, you must first determine the line at which your point and the origin go through the angle theta in the coordinates. So, let's say if we had a point that went through the line pi over 3, out right there. Alright, so we can represent it with this dotted line. It doesn't go through pi over 3. So, now we have our imaginary line. We can determine where the point is on this line with the r coordinate. Alright, so let's say our point is 2 units away from the origin. So we count 1, 2, and then we go and find that point on our imaginary line at our angle pi over 3.
Good point, Mr. Calvin. To graph a curve, you take an equation, r equals cosine theta, for each angle plugged in and obtain the radius and plot all the points. For r equals cosine theta, you have cosine pi over 2, which equals 0. Cosine pi over 3, it equals 1/2. Cosine pi over 4, square root of 2 over 2. Cosine pi over 6, square root of 3 over 2. And cosine of 2 pi is 1. All these points put together is going to give you a circle, approximately right there. Oh, hi guys. Sorry, I was taking a little break. You know what? I've been thinking now. I hate using the Cartesian plane. It's absolutely terrible. I always use the polar. So, here's how you convert the Cartesian to polar. You take r. You gotta have r to use polar. Take your r and use this equation. X squared plus y squared to the 1/2. Alright? Do that and get your r. Next, you need your theta. To get theta, you either use tan inverse of x over y or tan theta of x over y. That's how you do it.
He doesn't know this, but I do not like polar coordinates. So I changed all my coordinates from polar to Cartesian. And so this is how you do it. Don't tell him I showed you this. You take your r and your cosine of theta and multiply them together. And then you get the x-coordinate for your Cartesian plane. And for your y-coordinate of your Cartesian plane, you take r and multiply it with sine of your theta. Hey! Now we're on to taking the area of
polar functions. To take the area of a polar function is much like taking the area of a function on a Cartesian plane. Right? You take dx, which is your slice of pie on the Cartesian plane. The only difference is, for your polar function, it's going to be d theta.
Okay, so when you have d theta, basically it's a slice of pie that you take the area of the curve on your polar function. Okay? So each slice, d theta, has an area of 1/2 r squared, which is the radius, times theta, which is how big function right here. If this function is f of theta and is greater or equal to 0 for all of theta, then r can be replaced with the function. Okay? So then we have 1/2 times the function of theta squared times theta. Okay? Okay. So if you want to find the area of this
Whole
function
area.
under the curve,
Hold it.
of this function under a curve, we can, from alpha to beta, which is how much of the curve you want to take it under, you can take it and you can take the integral from alpha to beta of this, which is just the area of that slice, and you will get this integral in respect to theta. 1/2 times the integral from alpha to beta of your function squared d theta.
And now we're doing derivatives
The slope on the curve.
of polar functions.
Hey, Professor Caps,
Yeah.
what does this mean?
I thought you knew how to do derivatives.
I don't know. That's a lot of numbers and thetas and cosines.
Yeah. Yeah.
Who could? Wow. What are we gonna do?
We're trying to make a video here. We don't know how to do derivatives. Alright, I got just the person now.
You know, you do? Who?
My star pupil. Julie. Julie is going to do the derivatives for us.
Julie!
Julie's going to do the derivatives.
Julie!
Julie can do it. Yeah, Julie. Yeah. Julie can do it. Julie!
That wraps up for today, folks.